In this video, we're going to take a look at factoring. We're going to be looking at putting it all together in one problem. I am assuming that you have a basic background in factoring, as in you know how to factor out a greatest common factor, you know the difference of two squares, you can factor two perfect cubes or factor by grouping. Any of those basic factoring techniques you should already have mastered when you watch this video, because we're going to be putting it all together and putting all of those different types of factoring into the same problem. In this example, we've got 2x to the fourth plus 10x to the third minus 18x squared minus 90x. Alright, first thing that you should always do is go through and look to see if you can find a greatest common factor. In this, we do have a greatest common factor. It's going to be 2x. So greatest common factor in this one is going to be a 2x. So that's going to be the first thing I'm going to do. I'm going to factor out a 2x from each term. So I'm going to put the 2x on the outside, and then I'm just going to go through and take it out of each one of these. So a 2x to the fourth, factoring out a 2x, will leave me an x to the third. And then plus, if I've got a 10x to the third, when I take out 2, it's going to leave me with 5. X to the third, factoring out a single x, will give me an x squared. 18x squared, take out a 2x. 18 divided by 2 is going to give me the 9. X squared, factoring out an x, will leave me with 1x. And then 90x, taking out a 2x, the x's are going to go away. 90 divided by 2 is going to give me a 45 right there. Then once I get to this line, that 2x that I took out in front is just pretty much going to stay out in front, and it's going to come down in every line of work that I do. Then I'm going to focus on what's inside here. Generally, when you have 4 terms inside there, you're going to look to see if you can do factor by grouping. Alright, kind of looks like I'm going to be able to, so that's the first thing I'm going to try. To set this up for factor by grouping, I'm going to rewrite. I'm going to leave the 2x out there in front. I'm going to switch to square brackets here, because when I do my factor by grouping, I'm going to want to group those terms together on the inside. So I'm going to leave the outside brackets there and turn them into brackets, so that when I group these first two terms together, I can use the curvy parentheses, so maybe it'll be a little less confusing there. This is a negative 9 right there, so I'm just going to go ahead and include that minus sign in there when I group them together, and then that way I'll recognize it's negative 9 there. In each one of these terms, I'm going to, again, take out the greatest common factor. This 2x is going to just stay out in front. Out of this, I can take an x squared out as the greatest common factor. First term, if I start with x to the third and I take x squared out, I would be left with an x. 5x squared, taking out that x squared, is going to leave me with just the 5. Alright, now I'm going to come over here, I'm going to look at these two terms. I've got a negative 9x and a negative 45, so I'm going to factor out a negative 9 out of this. So I'm going to write it as a minus 9, negative 9, so it'll show up right there. Negative 9x, taking out that negative 9 would leave me with an x. Negative 45, taking out the negative 9 would leave me with the plus 5. Alright, and that's exactly what we want to happen when we do factor by grouping, because terms are separated now by add or subtract sign. So here's my subtract sign. So this is a term and this is a term, and in there I have a common binomial, so I can factor that common binomial out of those two terms, and I'm going to be doing it just inside these brackets. So the 2x is going to stay out here. I'm going to factor out the x plus 5 out of each of those terms. In this term right here, let's even distinguish that a little bit more. Here's a term, and here's a term. Okay, so in this term, when I take out the x plus 5, that's going to leave me with an x squared. Out of this term, when I take out the x plus 5, that's going to leave me with the minus 9. Now, what you're going to have to get used to in these types of problems is you never ever want to stop. Every time you do something, you're just going to keep looking to see if there's anything else you can do. The greatest common factor sitting out here in front, we can't do anything with that. The x plus 5, we can't do anything with that. But here you've got an x squared minus 9. You should recognize this as the difference of two squares. So I have yet one more step to do. I can leave that 2x there. And then at this point, leave the square brackets. Don't leave the square brackets. It really doesn't make any difference. I'm going to leave that x plus 5 there in parentheses. Now I'm going to take this difference of two squares and break that up into an x plus 3 and an x minus 3. Alright, for a final answer there. Okay, but that's what we're going to be doing in this video, just taking long problems and then doing lots of different types of factoring. So that's my first example. All right, for a couple other examples, let's see, let's take a look at this one right here. This one's kind of unique in a sense that we've got 4 terms. So you might think, oh, I've got to do factor by grouping. So you might try to start grouping these together, and you're going to see, you've got a greatest common factor here, but it's not really going to be here. Difference 2 squares. It's not really going to work out really nicely. So you've got to start thinking outside the box. Nothing says that you have to group 2 terms together all the time. If I look at this closely, this x squared minus 18x plus 16, if I group that together, that right there turns out to be a perfect square trinomial. Okay, so it's a perfect square. Okay, so perfect square trinomial. So kind of abbreviate that right there. Perfect square trinomial. I have a minus sign. And then this y squared over here, that's a perfect squared also. So this whole entire thing, when I group it this way, shows up as a difference of 2 squares. Okay. Now I am going to write an extra line in here. If I factor this the way you would factor a perfect square trinomial, you would end up with an x plus 4 quantity squared, and then minus the y squared. Okay, so here's my difference of 2 squares. This is a perfect square, and this is a perfect square. So I would need to take the square root of this one and the square root of this one, write them with a plus, and then write them with a minus. So I would do x plus 4, and then let's even put that in a different color so it stands out. So x plus 4 plus a y for my first term, and then for my second one, x plus 4 minus y. Okay, so factoring a difference of 2 squares, but doing it from 4 terms. And then you would want to look at what you have left here. I have no like terms. There's nothing I can do to simplify that or anything, so in this case that would be done right there. Okay, now 4 terms again. Alright, so again, you might try factor by grouping initially, and then you're going to look at that and go, okay, factor by grouping, the traditional way is not going to work. Alright, so again, start looking at, could you group 3 of them together? Well, this one's got to be plain term here. Alright, you should start recognizing that this is really close to a perfect square trinomial, except our signs are off just a little bit. So if I factor out a negative from this right here, okay, then I can rewrite. Okay, so that's what I want to do. I want to take a look at these 3 terms right here and take out a negative. Factor out a negative 1, and that's going to force my perfect square trinomial. So my a squared is going to stay here. Alright, minus. Now if I take it out, then take out a negative, I'm going to have a b squared here. That will turn that to a minus 10b. That'll turn that to a plus 25. Okay, and you can just check that, multiplying that back out, negative times b squared to give me that negative b, negative times negative would give me the positive, negative times positive would give me the negative there. Now you have a perfect square trinomial. So I kind of had to force it over here. Over here it was already set up. This time I had to force it to occur. Okay, but now I've got 2 perfect squares. If I go ahead and write that extra line in here, I'm going to see I've got an a squared minus, writing this in factored form, you would have a b minus 5 quantity squared. Alright, so these are both perfect squares, so I can write each of them with a plus and with a minus. Okay, so I'm going to do a, and then let's go ahead and keep it in a different color, plus the square root of this, b minus 5. That's going to be my first term. Okay, now when I write my second term here, a, it's going to be minus, but I have a binomial this time. So if I put that binomial in there, b minus 5. Alright, that's going to go through and that's going to change all my signs over here. Okay, so here's my plus and my minus that I have to have for my difference of 2 squares, but because I am subtracting a binomial, this is adding a binomial, this is subtracting the binomial, it's going to go through and change all my signs right here. So I'm going to have an a plus b minus 5. This one's not going to change. Alright, a, that'll stay a minus b. Okay, negative times negative on that 5 will make it a plus 5. Alright, so same concept, but because that perfect square trinomial ended up on the right-hand side, alright, you're going to have some signs that you're really going to have to pay attention and watch on that end part right there. Okay, a couple more examples. Trying to hit lots of different things here. Let's just go back to maybe say 2 terms, but just because it's got 2 terms doesn't necessarily mean it's going to be a short problem. Alright, first thing you always want to do, check for a greatest common factor. Looks to me like 3x is going to be my greatest common factor here. So if I pull that 3x out, 3x to the 10th, take out a 3x, that's going to leave me with an x to the 9th. 3x, take out a 3x, keep in mind you're dividing when you take it out, so 3x divided by 3x is going to leave you a 1, plus 1 right there, and that a lot of people make mistakes there and don't put anything there when you take that last term out. Alright, now looking at this on the inside, after you take out that greatest common factor, you always want to look inside there and see what you've got. You've got an x to the 9th plus 1. Alright, this is the sum of 2 cubes, because x to the 9th is a perfect cube and 1 is a perfect cube. Okay, now let's see if we remember the formula for that. Sum of 2 cubes can be factored into an a plus b, and then a squared minus ab plus a b squared. Okay, with your a and b being whatever the square root is there on each of those. Alright, so my a would be an x to the cubed, because that's the cube root of that, and my b would be a 1. Okay, and then if you've watched other videos of mine, I give a hint on how to memorize that as memorize the signs of all these. You can use your SOAP acronym. Alright, if you have a plus sign here, your SOAP acronym is meaning that this is going to be the same sign, this is going to be the opposite sign, and then this one will be always positive. So then there's a little SOAP acronym. Alright, on the perfect cubes. Alright, plus here. So that means same sign, opposite sign, always positive. So that will help you remember your signs on your perfect cubes there. Alright, now let's go ahead and attempt to factor this perfect cube here. I'm going to keep the 3x out in front. Alright, then I've got a plus b. So I'm just going to have an x to the 3rd plus 1. Now I've got to go through and I've got to square my a, so x to the 3rd squared would give me an x to the 6th. Alright, then it's going to be a minus. I'm going to take a times b, so I'm going to multiply these two. That would give me an x to the 3rd. And then I need to square b. b is 1, so that's going to be a plus 1. Okay, now again, you can't just stop as soon as you do one thing. You've got to go through and look at all of these again. Alright, this right here, the greatest common factor, you can never do anything with that. It's going to keep coming down. This right here turns out to be another sum of 2 cubes, because I can take the cube root of x to the 3rd, I can take the cube root of 1. Alright, this is a trinomial. This term is an x to the 6th, this term is an x to the 3rd, so it's half. So you could attempt to use substitution, see if this factors. I do not believe this is going to factor, so it's going to stay the same. But in some examples, you can have to factor this, and you might also have to factor this. So working on this being the sum of 2 cubes, I'm going to bring a 3x down, and then applying that same formula that we just had right there, I would have an x plus 1, and then squaring my a term, I would have an x squared minus x, and then plus 1. So that coming from that sum of 2 cubes right there. This term I'm not going to do anything with, so I would just leave it. X to the 6th minus x to the 3rd plus 1. Okay, now again, you'd go through here, check each one of these. This looks like another trinomial. You would need to check it, but looking at that, I can see that I'm not going to be able to factor that. I'm not going to be able to factor that one either, so I believe we have now factored this completely. Okay, so another example with just 2 terms over here, an x to the 10th plus a 512x. Again, just because it is 2 terms does not necessarily mean it's going to be a short problem. Taking out a greatest common factor, it looks like I'm going to be able to take an x out. So if I take my x out, I would have an x to the 9th, and then plus that 512. Alright, now looking here very carefully at this, x to the 9th, we know that's a perfect cube root. 512, that is also a perfect cube, being 8. Okay, so if I'm going to use the formula again that I used over there, my a term is going to be an x to the third, and my b is going to be an 8, because the cube root of 512 is 8. So factoring this as the sum of two cubes, the x is going to stay out in front. I'm going to have a plus b, so x cubed plus an 8. I'm going to square my a, so x to the third squared would be an x to the sixth. Alright, those two multiplied together, keeping the correct signs here, would be a minus 8x to the third. And then squaring my b term on the end would be a 64. Okay, now again, you've got to keep looking at everything. This turns out to be, again, another sum of two cubes, because x to the third is a perfect cube and 8 is a perfect cube. This would be a nice trinomial. You could try a u substitution on this one. You know, u to the squared minus 8u plus 64. And again, you can probably do that in your head. Pretty much you're not going to be able to factor that one. All right, if this would factor, you would also have to factor this as a trinomial. Since it doesn't, then I can focus on just this sum of two cubes right here. This x I'm going to keep and bring down. Cube root of x to the third is an x. Cube root of 8 is 2. So then I'll have an x plus 2. And then squaring the first term, I would have an x squared. Multiplying the 2, using opposite signs, I would have a minus 2x. Squaring that 2 would give me a plus 4 on the end. And then bringing the last trinomial down right there. X to the 6th minus x to the third plus 64. Okay, meaning these two coming from being the sum of two cubes. Now again, you would want to check each one of these. This looks like another trinomial. Alright, with your signs, could you factor it? You'd have a 4 and a 1 and a 2 and a 2. Not going to be able to get a negative 2 in the middle there. And again, you'd make sure that you couldn't factor that. And this one, I do believe that we're done because these two trinomials do not factor. Alright, and then we're going to do just two more examples, trying to hit lots of different type of scenarios that you might run into. Okay, so something like this, again, two terms, but they're a tad bit more complicated. I've got an x minus y here to the fourth minus 4x minus y squared. So this one, when I factor out a greatest common factor, my greatest common factor is going to actually be a binomial. So this would be factoring out a binomial, and not just a single binomial. I can take that x minus y squared out, because I've got two of them here, I've got 4 of them over here. So that's what I'm going to do first. I'm going to take out a greatest common factor of x minus y squared. So x minus y squared. Now I think I'm going to go to square brackets, because we've got an awful lot of curvy brackets in here. Okay, in this first term right here, I've got an x minus y to the fourth. I took 2 of them out, which means I'm going to be left with 2. So x minus y squared. The minus is going to stay there, the 4 is going to stay there. In this term, I took out the x minus y squared, so I'm just left with the 4. Alright, now again, you don't want to just stop after one factoring. You're going to look inside here to see what you can do with this. Okay, this is a perfect square, because it's a binomial being squared. 4 is a perfect square. I have a minus, so this is the difference of two squares. Okay, so this out here in front, which is what I brought out to begin with, is just going to stay x minus y squared. I think I'm going to go back to curvy brackets here on this one, because on this I'll have an x minus y, and then plus, because there's my difference of two squares, the square root of that there, which is a 2, and then I'll have the x minus y, and then the minus part of the difference of two squares, and then 2. So that breaking up there. Alright, and then looking at each one of these, I can't really do anything with this. Squaring that out would just make it more complicated, so I'm going to leave it alone. In here I do not have any like terms or anything, so again I'm going to stop. Alright, now for our last example over here, I went back to 4 terms, okay, but 4 terms we did usually factor by grouping, and then earlier in the video we showed you where you might have to group 3 things together. You might also, the first thing you might do is try rearranging those terms, because these 2 terms are x's and these 2 terms are y's. Alright, if you would do that, you would see that it's not going to get you anywhere. Alright, so in this scenario, you might want to go ahead and go with the first 2 and the second 2. Alright, and look at them more closely. Alright, this are both perfect cubes with the plus, so this would be the sum of two cubes. These are perfect squares with a minus in there, so this is going to be the difference of two squares. So the traditional grouping the first two and grouping the second two worked, but then what I'm going to do is two separate things. Okay, I'm going to factor this as the sum of two cubes. We're going to factor this as the difference of two squares. All right. Our a term would be an x, our y term would be a y there. So using that SOAP acronym, same signs, so I would have an x plus y, and then squaring that first term, x squared, opposite for SOAP, x times y, and then always positive on my end, and squaring that y squared. Alright, I am, like I said, I'm going through those, the sum of two cubes and difference of two cubes rather quickly because I'm assuming you do already have that down pat and mastered. Now, the one thing that you're going to want to be careful here is you factored these two things, and what I see a lot is when people jump in and start doing this is the difference of two squares, they just show it as multiplying all along there. Alright, you definitely want to make sure and bring that plus sign down in between them because you factored this by itself as the sum of two cubes, then there's the plus sign. Now I'm going to factor this as the difference of two squares. So then this factors really simply with just an x plus a y and an x minus a y. Okay. Alright, now here again, you don't want to just stop right there. You want to keep looking at everything that you've got there. Alright, this is a trinomial, and you could play around with that and see what you could come up with. I'm not going to be able to get a negative xy in the middle if I try to do that as a trinomial. Alright, however, if I look at this being my first term and this being my second term, I can look for a greatest common factor. I've got a binomial that is an x plus y here. In this term, I have also an x plus y binomial. So I can take out the binomial of x plus y. And I think I'm going to come down here just so I have a little bit more room to write. So I'm going to take out that binomial of x plus y. I think I'm going to go to square brackets. Don't really know that I would need to, but just in case. Now, everything left in this first term would be the x squared minus xy plus y squared. Out of this term, taking out that x plus y would leave me with x minus y. Alright, and then looking in here, rearranging terms would not necessarily help me. Regrouping anything's not going to help me, so I really think this one is complete at this point as well. Alright, so actually several long examples of just taking all the different factoring techniques that you have learned and putting them together in one particular problem. You're going to have to get used to what you see, looking for the different things such as like the sum of two cubes or the difference of two cubes, and never forgetting that greatest common factor because it's really, really important. Thanks for watching. Be sure to share with your friends and give me a thumbs up if you like. Thanks.